In this tutorial, we'll see how to match two ontologies within the Neon Toolkit with the help of the Neon Toolkit Alignment plugin. First, we need to create a new Neon Toolkit project. Having done so, we'll then import the two ontologies we wish to be matched. In the new project wizard, select the OWL2 ontology development project and proceed to finish. Now we should import it into an existing ontology from within our local file system by selecting OWL2 ontologies from File System. Then we can browse for another, which in this case is myonto2.owl. Now let's import the second ontology from the web by selecting Import Ontology from the web. We need to specify the physical URI of the ontology. The two ontologies can be found here. We can take a look at their classes in the Ontology Navigator. The range of classes listed here correspond to the bibtex classes, as well as a number of properties which correspond to attributes we find in bibtex objects. Now we can close this and open the Alignment plugin view. To do this, we go to Windows, Show View, Others, and it's now possible to select the Alignment plugin from the list. The Alignment plugin has two modes of operation, online and offline. We are, by default, in the offline mode, as indicated by the offline button being inhibited. This means that the program is only using resources held within the computer. It does not connect to the network. To begin with, let's look at how to use the plugin in the offline mode, after which we'll turn to the online mode. The upper part of the interface presents us with a list of ontologies which are currently loaded into the environment. We can select this one here, but leave this one. Or we can try to match these two ontologies. For matching the ontologies, we have a number of different methods at our disposal, and which, by default, are loaded with the Alignment plugin. We can select one of these, name EQ Alignment, which is a very simple method of matching ontologies and is based on matching entities that have the same name. Let's match them by clicking the Match button. This generates an alignment. Here we have number 1, which we can now view in more detail by opening View Alignment in the lower part of the interface. This is an alignment between two ontologies that have been loaded. We can see some metadata about the two ontologies, namely the two ontologies which have been matched and the method that has been used in order to achieve this. Take, for example, book. This will always have a certainty of 100%, and it doesn't match any other properties. This, therefore, isn't a very satisfactory alignment. So, returning to Methods in the upper part of the interface, we need to choose a more elaborate matching method. We'll choose instead the SMOA name alignment method, which develops a deeper analysis of names. Clicking Match generates a new alignment, which we can see here. This has now provided us with a second and a third alignment. We can see that it has given us more correspondences than before, although some of them are not very good, like organisation matches, in collection, for example. A number of others, however, do match, like abstract here and has abstract here, which is much better. But there are also things which are totally unrelated, like motion picture and in collection, which we can eliminate. This is now achieved by clicking the Trim button. The system now asks us for the threshold, so let's choose 0.7 or 70%. This generates a new alignment, number 4. Inspecting it further, we can see that the correspondences are much better than the previous set, and we have successfully eliminated the unwanted correspondences. So, given that we're satisfied with this alignment, We can now import it as an OWL ontology within the Neon Toolkit. To do so, click Import. We're then asked to give it a project name, so we'll create a new one. This project contains the two ontologies. Looking at this more closely, we can see that it imported the two ontologies, so it's a merger of these two ontologies. It also contains a third ontology, which corresponds to the alignment. We can now click on it to return to the Ontology Navigator, where it's confirmed to us that we have a merge. If we look at the source of this ontology, by clicking on the Source View tab at the bottom, we see that it contains axioms which represent the correspondences which were in the alignments. So, an affiliation in the BibTeX ontology corresponds to an affiliation in the OWL2 ontology, meaning that these are two equivalent properties. Looking further down, we'll see that article and article are equivalent classes, and that affiliation and has affiliation are equivalent properties. So basically, what we've done is to achieve an alignment which was produced as a set of OWL axioms connecting the two ontologies. Let's now return to the alignment plugin. So far, we've only considered the plugin in the offline mode. We can go to Online simply by clicking the Online button. In the online mode, we connect to an alignment server. In this case, the public alignment server provided by INRIA. Once we're connected, you can see that the two buttons have now been toggled. We now need to refresh the list to select the exact same ontologies as we had before. As we can see in the Methods chooser, there are more methods available from the server than before, such as this one from our colleagues in Montreal, Canada, or this one from INRIA Saclay. Many existing alignments stored on the server can be obtained by clicking the Find All Alignments from Server button. We can immediately see from the alignment chooser that there's a considerable number of alignments available for our use, even though we're interested in only a limited number at the moment. But we can ask the server for all those alignments that are between the two selected ontologies. This is achieved by pressing the Find Alignments for Ontologies button. We can easily inspect these alignments by selecting them and then inspecting them in the lower part of the interface. In this instance, we're sufficiently satisfied with our previous alignment, so we can select it and then upload it to the server simply by clicking Upload. The alignment server then confirms this with a registration number, in this case 158. Click OK. Having done so, it returns the URI that has been provided for this alignment on the server. We can check this directly on the server by finding all the alignments between the two ontologies. We can now see that there is one more alignment than previously. There are now 6 alignments available to us, of which our number 158 is featured in the list. So that finishes our tour of the workings of the alignment plugin. We very much hope that you'll use it for matching ontologies within the Neon Toolkit. If there are features you'd like to see added, then please don't hesitate to contact us. Thank you.